Hello, kids. Today we're going to learn about gas stoichiometry.
Now with more math.
Can't wait. Okay, so you know how to do stoichiometry, and we now know that moles can be related to liters or volume of gas at STP. So we're going to pull all of this together.
Avogadro's law, 1 mole at STP of anything is 22.4 liters.
Yep,
Right?
and that's on your reference materials if you forget. Okay, so this is a nice chart to show you how to solve these types of problems. So what you may notice is that we have our normal chart. So we have grams to moles to moles to grams, which you already know how to do. But now we have, now we have our standard volumes in here as well. So same thing, except you can convert to liters.
Okay.
All right, so now let's walk through how you would actually use this chart. So if I give you grams of A, and first we're going to go to moles of A. You can't compare anything unless they're in moles.
Okay.
So moles, the universal currency, we need moles first. So how do we go from grams of A to moles of A?
We would divide by molar mass.
Okay, so here we're going to divide by molar mass. You should all be super comfortable doing that now. Okay. Then we use mole ratio to go to moles of gas B. Again, should be super comfortable.
Still nothing different than what we've done before, right?
Right. And then, let's say I ask for liters of gas B. So now instead of going to grams, we're going to go to liters. So what would I do to go from moles to liters?
So if you want to go from moles to liters, you have to multiply moles multiplied by 22.4 liters, because that's how many liters there are in 1 mole. And you can only do that if they tell you that this reaction is taking place at standard temperature and pressure. Make sure you know that. It takes place at STP, at Stony Point High School. That's when you have to use it.
Okay. So now let's walk through a problem.
All right. So let's do your typical combustion problem. We'll do like the combustion of methane. And so that's your CH4 plus a couple of O2s are going to yield you your normal products for combustion, which are carbon dioxide and a couple of waters. So this is already balanced for you. And so what are we actually trying to look for here?
So let's say we start with 10 liters of methane.
Okay.
And I want to know liters of carbon dioxide. So we're just going to go from liters to liters.
Okay, but I can't go from liters to liters directly without going through moles and mole ratio first.
Right.
All right, so can you show me how to do that?
Okay. So if we start with 10 liters of CH4, and we're going to do this in 2 steps. If you're comfortable setting up one long train track, certainly welcome to do so. Okay, so how many liters are in 1 mole?
22.4 liters in 1 mole. And this, again, we're assuming this takes place at standard temperature and pressure.
Okay, so liters are here, they cancel out. I'm solving for moles. So I end up with 0.446 moles of methane.
And always put moles of CH4 or whatever your compound is. That way you can keep track, especially when you do your mole-to-mole ratio.
Okay, so now let's do 0.446 moles. So I know I have that many moles of methane. How do I get it to moles of carbon dioxide?
To go from moles of one thing to moles of something else, you have to use mole ratio, which is the coefficients of your balanced equation.
Which is 1 mole of CO2 to every 1 mole of methane.
Made it quite easy for you guys this first run through.
But make sure you still set this up even if it's 1 to 1. Because again, my moles of CH4 cancel, converting to moles of CO2.
And it actually would just be 0.446 again. It's a 1-to-1 ratio, so for 0.446 moles of methane, you're going to get 0.446 moles of CO2.
Yep, so then...
One more step, right?
One more step, because we want to go to liters. So 0.446 moles of CO2. And I'm going to liters, so I need 22.4 in the numerator. Oh, this is super messy. 4 moles of CO2. And I end up with...
What do we end up with? We end up with 10 liters of carbon dioxide. Now you might see that, yeah, okay, we started with 10 liters, we ended with 10 liters. Okay, no big deal. You're not always going to end up with the same amount of liters that you started with, but in this case we did. It just so happens. But that's just a really good way to go from volume to volume. What if I was given grams to start with of something and I wanted to go to liters of a gas?
So let's do one that's a little bit harder. Okay.
All right, so we'll do
magnesium metal.
Okay.
Plus hydrochloric acid. gives us magnesium chloride and hydrogen gas. Okay, so what do you want to solve this time?
Well, I want to know, so if I start with 5 grams of magnesium, if I start with 5 grams of magnesium, I want to know how many liters of H2 gas, hydrogen gas. So how many liters of that does 5 grams of magnesium make, assuming that I react it at standard temperature and pressure with enough hydrochloric acid?
So we're going to go from grams to moles, moles to moles, moles to liters.
3 steps. So let's do those 3 steps.
Okay. So we have 5 grams of magnesium. You know what the molar mass of magnesium is off the top of your head?
It is 24.305 grams. And that definitely wasn't written down on a paper.
Never. Okay, grams cancel. We're solving for moles. So how many moles do we end up with?
0.206 moles of magnesium.
Okay, so that's our moles of magnesium. And now we need to
go from moles of magnesium to moles of hydrogen gas. So mole to mole ratio. What are our 2 coefficients?
Same thing, we have 1.
1 and 1, which is kind of nice. But always make sure you have a properly balanced equation to make sure that your mole ratio works out.
Yeah, because they won't always be balanced.
They won't always be balanced for you. So we also, 0.206 moles of magnesium will be 0.206 moles of hydrogen gas. But we got one more step to do, and that's to find liters. So we're not doing molar mass anymore. We're doing that molar volume thing. So if we have, what do we have to do? We have to multiply it by the molar volume of any gas, which is 22.4 liters per mole.
And that equals
4.61 liters of hydrogen gas.
Of H2. So let me box that because that's our final answer.
So we've now gone from volume to volume using mole ratio in between. And now we've gone from grams to volume. This is all at standard temperature and pressure. This should take care of anything that you guys need to solve any of these types of problems. You'll definitely see these again.
So first thing, balance your equation.
Okay.
Write whatever you're given underneath the element or the compound and figure out what you're trying to solve for. And think about your steps before you start setting everything up. Then you should be fine.
Sounds like good advice.